Mathematics, Analysis and Approaches, Paper 1, Timezone 1, HL, November 2025. Question number 10, this is of 18 marks. It's a question from section B and hence a bit extensive in nature. Here he gives us an expression which is 1 over 1 plus x squared, and he wants us to find the expansion of it using binomial expansion, of course, and you will end up with something like that. Also, he has given us another expression for which again we're going to be applying binomial expansion to get some terms, and then using that we're going to find out the approximation of a certain number. Now, integration of 1 over 1 plus x squared is basically tan inverse of x, and which is arctan x, and integration of 1 over root of 1 minus x squared is going to be arcsin of x. Using that I can find the approximation of 1 over 2. He wants us to find a value for k if it is equated to that, and then he wants us to find the approximation of pi in the form of p by 640, where p belongs to the positive integers. Very simple. Let's look at the binomial expansion for rational coefficients. The binomial expansion for rational coefficients can be written like that: 1 plus nx plus n into n minus 1 into x square divided by 2 factorial plus n into n minus 1 into n minus 1 into n minus 2 into 3 factorial divided by 3 factorial into x cube, and this continues. I'm going to write one more term over here, divided by 4 factorial into x to the power of 4. Okay, great. So let's look at 1 by 1 plus x squared. I can write this as 1 plus x squared whole to the power of negative 1, and the expansion of this is going to be 1 plus minus 1 into x, which is x squared over here, plus negative 1 into negative 2 divided by 2 factorial into x squared, the whole square, which is x to the power of 4, and negative 1 into negative 2 into negative 3 divided by 3 factorial into x squared, the whole cube, which is x to the power of 6. I want to see if I need to stop it there. Yes, he wants us to stop it there. First 4 terms is all he wants, and I have the first 4 terms: 1, 2, 3, 4. Let's simplify this. 1 minus x squared plus 2x to the power of 4 divided by 2. This is going to be negative into negative into negative, which is going to be negative again. So 3 factorial is nothing but a 6, so 2 3 is a 6, that will get cancelled. So I'll simply remain with minus x to the power of 6. So finally the expansion up to 4 terms is simply that, and we got that. Hence find the approximation for integration of 1 over 1 plus x squared. Now the integration of 1 over 1 plus x squared, again this is an approximation, not the entire expansion. So integration of 1 minus x squared x to the power of 4 minus x to the power of 6 dx, which is simply going to be equal to x minus x cube by 3 plus x to the power of 5 by 5 minus x to the power of 7 by 7 plus the constant c. Wonderful. Now I'm going to use the same thing to term x to the power of 7. Did I have x to the power of 7? Yes, I did. Okay, let's use this to expand until x to the power of 4. So integral of 1 divided by root of 1 minus x squared, or let's actually first apply the binomial expansion. This can be written as 1 minus x squared whole to the power of 1 over 2, negative 1 over 2, and then I apply the expansion 1 plus nx, which is minus 1 over 2. X here itself is negative, so I'm going to write it like that, plus minus 1 over 2 multiplied with minus half minus 1 is going to be minus 3 by 2 multiplied with minus x squared whole square, and this is going to be divided by 2 factorial plus, how many terms does he want? Up to x to the power of 4. I think we can stop it here because the next term is going to be x to the power of 6. So this can be written as 1, negative into negative is a positive, x squared by 2, negative into negative is positive. The next term is going to be a positive because this entire thing has been squared. So I'm going to have a 3 by 4 into 2 factorial, which is simply a 2, and this is x to the power of 4. Nothing get cancelled, so I can continue writing this as 1 plus x squared by 2 plus 3 by 8 x to the power of 4, and this is 1 by root of 1 minus x squared. This is the expansion of it. Alright, let's go to the next part. The next part talks about, okay, hence find the polynomial expansion. So I now need to integrate this. Let's go ahead and integrate that. So this is integral of 1 by root of 1 minus x squared dx is going to be integral of 1 plus x squared by 2 plus 3 by 8 x to the power of 4 dx, and this is a very simple integration. X plus x to the power of 3 by 3 into 2 is going to be a 6, plus 3 x to the power of 5 divided by 8 into 5 is going to be 8 5s are 40, so that's plus c. So that's your integration of 1 by root of 1 minus x squared. Easy until this point. So the expansion so and so can be used as an approximation for sine inverse of 2. Let's now look at, as I said, integration of 1 by root of 1 minus x squared dx is nothing but arcsine of x. So arcsine of x can now be written as x plus x cubed by 6 plus 3x to the power of 5 by 40 plus some constant c. So let's see what happens when I substitute a half into that equation. So when I substitute a half, I will have arc sine of half is going to be equal to 1 over 2 plus 1 over 2 cube by 6 plus 3 into 1 over 2 to the power of 5 divided by a 40, which is 1 over 2 plus this is going to be 1 over 8, 1 over 8, 8 5 is 48, 6 is 48, plus this is 3, 1 over 2 to the power of 5 is going to be 32 into 40. Now how much is 32 into 40? Let's calculate that. 4 2 is 8, 4 3 is 12, 1280. So the reason why I multiplied is because I need this number here, right? And this is 25 by 48, so I should get a 25 by 48 once I add this up. So I'm going to multiply this with a 24 plus 1 divided by 48 plus 3 divided by 1280. So that's 25 by 48 plus 3 times of 1280. That's arc sine inverse sine of 1 over 2, which basically tells me that the p value is a 3. K value, sorry, not the p value. K value is a 3. So this is what I end up with. I know that arc sine of half is going to be so and so, but I also know that arc sine of half is pi by 6, and that's going to be equal to 25 by 48 plus 3 over 1280. Well, I'm going to transpose this. This is going to become 25 into 6 divided by 48 plus 3 into 6 divided by 1280. So 6 ones are 6, 18 divided by 1280. I don't have another option than to actually take an LCM over here. I'm just thinking, what if we could reduce this a bit before we can take an LCM? to 640. This is not further divisible, and hence approximate value for pi is going to be that much. For that, when you're writing the approximation, use this symbol, not the equal to symbol. All right, though I have mentioned equal to all over, make sure that you use the approximation symbol, because all these are approximate, these are not exact values. All right, so all these places you may have to write an approximation. That is it for this video. Thank you.